Good morning, students.
Good morning, ma'am.
All of you, please switch on your videos. Out of the 62 students, I can see only very few of your faces on the screen. What about others? Please switch on your videos. Okay, children. So in our previous class, we discussed the vector addition using component method. So in order to explain this vector addition using component method, we explain another topic in physics. That is what you mean by resolution of vectors. Okay, then Emmeline, what do you mean by resolution of vectors?
Ma'am, we can split the single vector into different component is known as.
Okay, the splitting of the single vector into two or more vectors are called the resolution of vectors. Then what do you mean by rectangular components, John Joes? Rectangular components.
Ma'am, if they are perpendicular to each other.
Okay, if the component vectors, that is the vectors that we are obtained after the splitting process, and if the component vectors are mutually perpendicular to each other, we can call them as rectangular components. Okay, all right. Then Devi Krishna, what is the equation for calculating the vector addition using component method in two dimension?
Vector A is equal to ax I cap plus ay j cap.
Vector A is equal to ax I cap plus ay j cap. Gaya Mary, what is the equation for calculating the vector addition using component method in three dimension?
Ax I cap plus ay j cap plus az k cap.
Okay, vector A is equal to ax I cap plus ay j cap plus az k cap. So this is the equation for calculating the vector addition using component method in three dimension, where ax, ay and az are the magnitude or the components of the vector A, and I cap, j cap, k cap represents the unit vector along the x-axis, y-axis and z-axis respectively. So now we are going to find out we are going to derive an expression for calculating the magnitude of the vectors. Okay. Equation for calculating the magnitude. That is, in the previous class, we derive an equation. Vector A is equal to ax I cap plus ay j cap plus az k cap. If it is in three dimension, the equation is az k cap. Okay, where ax, ay and az, they are represents the magnitude of the vector A along x-axis, y-axis and z-axis respectively. That is, ax is the magnitude. As is the magnitude along x-axis, magnitude of vector A, along x-axis, and I cap represents the unit vector along x-axis. Okay. Similarly, ay j cap, where ay is represents the magnitude of vector A along y-axis, and j cap is represents the unit vector along y-axis. Similarly, az represents the magnitude of vector A along z-axis, and this k cap is represents the unit vector along the z-axis. So this equation is actually comes from the general expression a cap is equal to magnitude of vector A into unit vector A cap. So this is the general expression that we are used here. So from this equation we form vector A is equal to ax I cap plus ay j cap plus az k cap. So this ax, ay and az represents magnitude of vector A along x-axis, y-axis and z-axis respectively. Now we want to find out the value, how we can calculate the magnitude That is how we can calculate the magnitude of a vector. That magnitude of a vector is represented like this, modulus of vector A. So now we are going to discuss how we can calculate the magnitude of a vector. That is what we are going to discuss next. So all of you write the next heading. Calculation of magnitude of a vector or equation of magnitude of a vector. Calculation of magnitude of a vector. Calculation of magnitude of a vector. So in order to explain this magnitude of a vector, in order to derive an expression for magnitude of a vector, we consider the same graph that we are taken in the previous class. That is, we have a vector, a single vector, vector A, which is inclined at an angle theta. So we resolve this vector A into two components. One is a horizontal component and the other is a vertical component. So this vector A with the magnitude A having the coordinates AX, AY. So here this point is corresponding AX, 0 to AX. Similarly, this point is corresponding AY, from origin to AY. And this single vector A is inclined at an angle theta. We consider the same graph. So from the same graph, we can derive the expression for magnitude of a vector. Okay. So this length is represents AY. AY. This is the vertical line. Vertical line, the line that is parallel to that of the y-axis. Here we have y-axis, here we have x-axis. So this length is represents AY. Similarly, this length is represents AX, the line that is parallel to x-axis. Okay. Now, from this graph, what is sine theta? What is sine theta? Sine theta is equal to opposite side divided by hypotenuse. Or we can write sine theta is equal to, what is opposite side here? Yes,
AY.
AY. Here we consider the sine theta. Sine theta means opposite side divided by hypotenuse. So here the opposite side is AY. So the equation becomes AY divided by hypotenuse. Hypotenuse is nothing. It is the resultant vector or the previous single vector, vector A with the magnitude equal to A. So the equation becomes AY divided by A. So sine theta is equal to AY by A, which implies AY is equal to, if sine theta is equal to AY divided by A, then AY is equal to, what is AY? Just to rearrange the equation, AY is equal to, take the A
sine theta.
Yeah, A sine theta. A sine theta. This is our equation number 1. Sine theta is equal to opposite side by hypotenuse. So from the figure, it is clear that the opposite side is AY. Hypotenuse is represented by the resultant vector, vector A with the magnitude A. So when we substitute the value into the equation, it becomes sine theta is equal to AY by A, or we can write AY is equal to A sine theta. This is our first equation. Now from the same figure, we can find cos theta. Cos theta is given by, cos theta is equal to, what is the equation for calculating cos theta? Adjacent side divided by hypotenuse. adjacent side divided by hypotenuse. Or we can write cos theta is equal to adjacent side. From the figure, what is the adjacent side here? This is our cos theta. What is the adjacent side? This represents the adjacent side. This represents adjacent side. That is our AX. AX minus 0 is AX with a magnitude AX itself with hypotenuse. Hypotenuse is the same. It represents the resultant with the magnitude A. Vector A with the magnitude A. So the equation becomes AX divided by A, which implies AX is equal to, if cos theta is equal to AX by A, then AX is equal to A cos theta. This is our equation number 2. AX is equal to A cos theta. Now, in the next step, write the statement, square and add equation 1 and 2. Square and add. Two operations should be there. First of all, you first square the equation 1 and equation 2. Square the equation on both terms of the sides, from both sides, and then add equation 1 and equation 2. Square and add equation 1 and equation 2. That is equation 1 square plus equation 2 square. Equation 1 is this, AY is equal to A sine theta. While we are squaring the equation, it becomes A square Y is equal to A square sine square theta. Right? Similarly, we are going to squaring the equation 2. When we are squaring the equation 2, this is our equation number 2. AX is equal to A cos theta. When we are squaring on both sides, we get A square X is equal to A square cos square theta. So the squaring is over. Square the equation 1 and equation 2. Squaring on both sides of the equation 1 and 2. Then add these equations. So it becomes add the LHS first. A square X plus A square Y is equal to, what is the LHS of RHS of the equation number 2? A square cos square theta plus A square sine square theta. A square X is A square cos theta. A square cos square theta. A square cos square theta plus A square Y is A square sine square theta. So it is A square sine square theta. So we get A square X plus A square Y is equal to A square cos square theta plus A square sine square theta. Which term is common in this case in the right hand side? A square. A square is common. We can take it outside. So it becomes A square into cos square theta plus sine square theta. What is cos square theta plus sine square theta?
1.
Yes. In mathematics, we already studied that cos square theta plus sine square theta or sine square theta plus cos square theta is equal to 1. In trigonometry, sine square theta plus cos square theta is equal to 1. That is, this entire term is equal to 1. So our equation becomes A square is equal to AX square plus AY square. A square is equal to ax square plus ay square, which implies A is equal to, what is A? A is equal to, A square is equal to ax square plus ay square, which implies A is equal to root of ax square plus ay square. This is the equation for calculating the magnitude of the vector. So here we consider a single vector, vector A, with the magnitude equal to A. So the magnitude of the vector can be calculated by finding the square root of ax square plus ay square. Ax square plus ay square. A is equal to root of ax square plus ay square. So once again, we can recollect all the equations in 2 dimensions and 3 dimensions and represent them in their vector form and the corresponding magnitude of that particular vector. Okay, so the magnitude of a vector is given by A is equal to root of ax square plus ay square. So in two dimension, vector A is represented by, vector A is equal to, we know that axi cap plus ayj cap, axi cap plus ayj cap. In two dimension, vector A is equal to axi cap plus ayj cap. And magnitude of the vector A is given by, magnitude is given by A is equal to root of ax square plus ay square. So this is the case for two dimension. This is the vector representation, and in the second equation we find the magnitude of vector A. Magnitude of vector A is given by A is equal to root of ax square plus ay square. Now, similarly, students try to form an equation in 3 dimension. In three dimension, vector A is represented by, vector A is equal to axi cap plus ayj cap plus azk cap. Then magnitude of vector A in 3 dimension becomes A is equal to root of ax square plus ay square plus az square. In 3 dimension, vector A is represented by axi cap plus ayj cap plus az cap. Then the magnitude of the vector can be calculated by A is equal to root of ax square plus ay square plus az square. Now write one question. We can solve this with the help of this equation using vector addition by component method. You can expect the question like this. Write one question. Vector A is equal to 5i cap minus 3j cap. Vector A is equal to 5i cap minus 3j cap. Then calculate the magnitude of vector A. Students, can you identify in which dimension the object is moved? Here the vector is represented by 5i minus 5i cap minus 3j cap. So the motion of the object takes place in a plane, it's sure. That is why we are representing in the vector form. And what about its dimension? Does the object is moves in a 2-dimension or 3-dimension?
2
Yes, it is very good because it is moves in 2-dimension. We are representing the unit vectors in terms of I cap and j cap. That is, it is representing the unit vector along the x direction and y direction only. Then how we can calculate magnitude of vector A? Magnitude of vector A. What is the equation for magnitude? Calculating the magnitude of vector A is equal to root of ax square plus ay square. In 2-dimension, the magnitude of vector is calculated by A is equal to root of ax square plus ay square. That is equal to root of, what is ax here in the given question? Ax 5. So 5 square plus ay is minus 3. So it is minus 3 the whole square. So it becomes root of 5 square plus minus 3 square. That is 5 square means root of 25 plus 3 into 3, 9. Root of 25 plus 9. What is the answer? Magnitude of vector A. Root
34.
34. So the answer is root 34. That's all. So magnitude of vector A is root 34. Magnitude of vector A is root 34. This is our answer. Right, one more question. Consider vector A is equal to 6i cap plus 4j cap plus 2k cap. Calculate the magnitude of vector A. Calculate the magnitude of vector A. Vector A is equal to 6i cap plus 4j cap plus 2k cap. Then calculate the magnitude of vector A. So from the given vector itself, it is clear that the object is moves in a 3-dimension, 3D. So we need to choose the equation for calculating the magnitude of vector along 3-dimension. That is, magnitude of vector A is given by A is equal to root of ax square plus ay square plus az square. Find ax, ay and az. Six square plus 4 square plus 2 square. It becomes A is equal to root of, what is 6 square? 36 plus 16 plus 4. What is the final answer, Nimita? Nimita, did you get the answer?
Ma'am, root 56.
Yes, root 56, right. Right, Mary, root 56. Okay, is it clear how we can calculate the magnitude of the vectors if the vector is given? Whenever the vector is given, we can easily calculate the magnitude of vector using the equation root of ax square plus ay square plus az square. We just need to add the components of the vector along the x, y, and the z directions respectively. Not only add, by after the squaring. Square root of ax square plus ay square plus az square. Okay. Now, we can consider another case. If we have two vectors, if we have two vectors such that vector A is equal to, if we have two vectors such that vector A is equal to ax I cap plus ay j cap plus az k cap. If we have two vectors such that vector A is equal to ax I cap plus ay j cap plus az k cap, and vector B is equal to bx I cap plus by j cap plus bz k cap. Suppose we have two vectors. Vector A is equal to xi cap plus ay j cap plus az k cap. And vector B is equal to bxi cap plus by j cap plus bz k cap. Then how we can add these two vectors? Vector addition by component method. The vector addition by component method for adding the two different vectors is given by. Then vector A plus vector B is equal to, we need to add the components along the x direction. That is ax plus bx into I cap plus add the components along the y direction in both cases. So it becomes ay plus by j cap. The components along the z direction. That is az plus bz into k cap. Vector A plus vector B is equal to ax plus bx into I cap plus ay plus by into j cap plus az into bz k cap. So this is the general equation. If we have two vectors, vector A and vector B, then add the components of these vectors along the x direction plus then along the y direction and z direction. Now all of you write one question. Consider vector A is equal to 5i plus 2j, 5i plus 2j cap minus 3k cap. Vector A is equal to 5i cap plus 2j cap minus 3k cap. And vector B is equal to I cap minus 3j cap plus k cap. Vector A is equal to 5i cap plus 2j cap minus 3k cap. Vector B is equal to I cap minus 3j cap plus k cap. Find the sum of these two vectors. Find the sum of these two vectors. Vector A plus vector B is equal to, what is the answer? Shabarinath, did you get the answer?
Yes, ma'am.
What is the answer?
6i cap minus j cap minus 2k cap.
6i cap minus, here plus 2 and minus 3. So it becomes 2 minus 3, become minus 1. So minus j cap. In the last term,
Minus 2k cap.
minus 2k cap, right? So vector A plus vector B is equal to, add the components along the x direction, that is 5i cap plus I cap. Here I cap means 1 I cap. So 5 plus 1, it is equal to 6 I cap. In the second term, that is the components along y direction, that is why it is represented by j cap. So 2 plus minus 3. So in effect, it becomes 2 minus 3. So we just subtract and give the sign of the bigger number. So it becomes minus 1 j cap. So we can simply represent them as j cap itself. And the last term, minus 3 plus 1. Minus 3 plus 1. Subtract and give the sign of the bigger number. It becomes minus 2. So vector A plus vector B is equal to 6i cap minus 1 j cap, or you can simply write as j cap minus 2k cap. Write one more question. By analyzing your answer sheet, I understand one thing. Most of them are not aware about the derivative. Take the derivation. So we can solve one problem from this chapter like that using the derivation steps. I will give you some basic derivation step. D by dt of a constant, d by dt of x raised to 1, d by dt of sine theta. Did you study that formula? Okay. Anyway, all of you, is it clear? This problem is clear to you?
Yes, ma'am.
Okay. Write one more question. The position of a particle is given by, one word problem. The position of a particle is given by vector r is equal to, the position of a particle is given by vector r is equal to 3t I cap, 3t I cap minus 2t square j cap. The position of a vector is given by, position of a particle is given by vector r is equal to 3t I cap minus 2t square j cap plus 4k cap, 4k cap meter. So here t is in second, and r is in meters. Okay. Then the question is this: find the velocity v. Find the velocity v and acceleration a. Find velocity v and acceleration a. Find velocity v and acceleration a. Second sub-question: what is the magnitude of velocity of the particle? What is the magnitude of velocity of the particle? T is equal to 2 seconds. At t is equal to 2 seconds. This is the question. Vector r is equal to 3t I cap plus 2t square j cap plus 4k cap in meters. This represents the position of a particle. First question is this: find the velocity v. So here we are representing its vector v because velocity is a vector quantity. That is why we put the arrow mark over this letter v. And acceleration a. A is also a vector quantity. Acceleration is a vector quantity that is also represented by the arrow mark. So find the velocity v, vector v, and acceleration vector a. Second sub question: what is the magnitude of the velocity vector, vector v of the particle at t is equal to 2 seconds? So we can resolve the first problem. Find the velocity v and acceleration a of the particle. So here in this question, we have the position vector r is equal to, what is the position of this particle, vector r? Vector r is equal to, is given 3t I cap minus
2t j cap plus 4t cap.
2t square j cap plus 4t, right? 4k cap. This is the position. And the first sub question: find the velocity vector v. Find the velocity vector v. How we can find out the velocity? What do you mean by velocity? What do you mean by velocity? Recall the concept from our previous chapter, motion in a straight line. What do you mean by velocity? Rate of change of displacement, right? Rate of change of displacement. So here the position is given. Position is nothing, it is the displacement of the particle. So here instead of x, they are representing by r. So how we can find out the velocity? Velocity means dr by dt, the rate of change of position of an object or the rate of change of displacement of an object. So here we want to find out the derivative of the position, that is d by dt of vector r. Vector r means 3t minus 2t square plus 4. Or d by dt of 3t I cap 2t square j cap plus 4k cap. Find the derivative. That is d by dt of, this is in bracket. So d by dt of 3t minus d by dt of 2t square plus d by dt of 4k. What is d by dt of 3t?
3.
3. d by dt of 3t means it is 3 minus d by dt of 2t square
40.
is 4t. 3 minus 4t plus d by dt of 4. D by dt of a constant. 4 is a constant. It's a number. D by dt of a constant is equal to
0.
0. So plus 0. So the velocity becomes vector v is equal to 3 minus 4t. Okay, children, it's a time. We can discuss the same problem in our next class.